Okay, so we've been talking about angles and stuff like that in the basic geometry. We're going to take a little bit of a different view right now, and it's going to come back together again. But we're going to talk about this symbol right here. What's that symbol mean? Most of us call it the square root symbol. Its technical name is the radical symbol. Most of us have seen it used like this, where it's asking us what is the square root of 16. But it can be used for other things. It can be used like this. Notice the difference there is a little 3 here. That's saying that it's still a root, but it's not a square root. That's a third root, yes. So let's look at what this symbol, what it means when we use it like this first, and then we can come back to what this means. The square root symbol, square root of 16, is asking us what number squared equals 16. Careful. 4 squared equals 16. So the square root of 16 is 4. What's the square root of 25? Most of us would call that, or if you punch in your calculator, it would come up with do you guys know how to do square root on your calculator?
No, where is it?
I mean, most of you have an x squared key on your calculator somewhere.
Yeah.
Above that, written on the calculator, is a square root symbol. So what you have to do is you either have to do second or shift, depending on your calculator, then that key, and then type in the 25 and hit equals. It should give you 5.
So it's second.
Second, then that x squared key, which has the square root symbol right above it. Yep. And then the 25, and hit equals. Should give you 5. Something went just a little bit wrong there. You did 5. You did put 5 in there instead of 25. Syntax error? Let me take a look. Although, even though the calculator says 5, 5 is not the only possible answer there. Remember, we said that symbol is asking us what number squared is 25. 5 squared is 25. But there's another number that when we square it equals 25. Can anybody tell me what it is? Negative 5 squared could also be 25. So technically, when we do a square root, there are 2 answers. The square root of 25, the calculator will tell us 5, but there could also be an answer of negative 5 as well. So like the square root of 81, if you punch that in your calculator, what's it going to give you? Nine. Good. Or negative 9. Good. The calculator won't give you the negative 9. It just tells you 9. But we know that it could also be a negative 9, because negative 9 squared would also equal 81. What's the square root of negative 100? Give it a try.
Well, it doesn't work.
Calculator says error, yes. You did domain error. What does that mean? Well, remember, this is asking us what number squared is a negative 110.
Well, you can't do that.
We can't.
Because 2 negatives make a positive.
Exactly. No matter whether it's a positive number or a negative number, if we square it, the result is going to be positive, no matter what. There is absolutely nothing that we can square to get a negative. So we cannot do the square root of a negative. Now I'm going to say that with one qualification.
Oh.
There is a branch of algebra called complex algebra, imaginary algebra is part of it. Complex would be the next step up, where they define the square root of -1 to be this symbol I, and then they create a whole system of algebra around that. We're going to stick to what we call real numbers in here. Real meaning they actually exist in nature, because that's the most useful. Now that imaginary algebra does have applications in complex electronics and circuit analysis and stuff like that. Start getting into circuit phasors and inductive circuits and capacitive circuits and stuff like that. Yeah, the imaginary numbers actually do come into that analysis. 99.9% of you will never ever care about an imaginary number, so we're not going to talk about it. For our purposes, we're going to say that you cannot take the square root of a negative, period. So now I promised you that we would look at that symbol here, the third root of 8. If the square root is asking us what number to the second power is that, this is asking us what number to the third power is 8, which would be 2. 2 to the third power is 8. Well, your calculator has an X root key somewhere. Usually it's on your caret key. It's above your caret key. So to do that, you have to put in the 3 first. To tell it this is going to be a third root. So you do 3, and if hit the second key, then that caret key, which has the X root above it, and then the 8, and hit equals. Should give you 2. Now, just for fun, what would we get if we tried to do the third root of a -8? So you enter the 3, second. Somebody said -2. Maybe we do. It is -2 because it's a third power. -2 to the third power is a -8. Since it's an odd power. Remember, when we were doing powers, even powers, like the power of 2 or 4 or 6 or 8 or 10, always come out to be positive. But the odd powers could be negative. A third power of a negative number is going to be negative, or the fifth power of a negative number will be negative. So since this is a third root, we can find the third root of a negative number. Just like we could find the fifth root of negative, what do I want to do here? 3,125. What's that going to be? -5. Very good. Or the third root of a -512. Did you get -5 for this one? So on your calculator, you have to enter 5, second, caret, yep, and then -3,125. Can't use the minus, you got to use the negative key. Down by the equals sign, it's got the parentheses around the negative. That. What'd yours do? There we go. For the third root of -512, did you get -8? Perfect.
And so you can do that with the negative, but up on top, where you said the -100, it won't work.
Why did that not work?
I don't know why.
Because it's a square root.
Okay, so square root ones don't
Yep.
work, but
Just like this one wouldn't work. The fourth root of 81 would be 3, but the fourth root of negative 81 can't be done because it's an even root.
Oh, even ones don't work.
Even ones, you can't use negatives. Yep. Because remember, if you're doing an even power, the result's always positive.
No, that's too much for me to just remember off the top of my head. I have to
I
write
know.
that down and look back 20 pages.
That's why we're going over it again. So why are we doing all this stuff with roots right now? To be honest, the only thing we really care about right now is the square root. Because getting back into the geometry side of things, we're going to be using it in our triangles. So let's focus on that square root a little bit more. Like the square root of 0.64. This one always seems a little weird at first because we took a square root, but the result we got was bigger than what we were started with.
Well,
The square root of 0.64 is 0.8. But remember, 0.8 times itself, or 0.8 squared, since you're multiplying by something smaller than 1, it's going to get smaller. You look confused, Billy.
Why am I not getting that?
Just all you're going to do is just the square root key and then 0.64. You don't have to put anything before it. You're not using the caret key now, you're using the x squared key, second x squared, for square root. Yeah, you hit the second key first.
Oh,
Yep. Then x squared, because that's the square root right above it.
thank God I'm not gonna have to use this for once we do it for a couple hours, it'll make sense.
Well, and it's just like any other math class you take. There are going to be a few things that you will use in your job, and those things you'll remember and remember them well, and everything else you'll forget.
Is this stuff I'm not gonna have to use?
Depends on what you end up doing.
Business?
There's some roots and stuff that you would use if you got into the right area of business. Google everything. But like I said, once you get into it and you use it, at least a couple times a week, you start to remember it.
Are you gonna be using this stuff in that next class I'm taking?
Roots, not so much. But there are some pretty complex formulas in there. Powers we use a lot. So we're talking about compound interest and annuity calculations. Percents we use a lot.
You're really gonna do it.
We'll get you through it, don't worry. How about this? Square root of 9/16. Now on your calculators, remember you have that fraction capability. So it's going to be second, then the x squared, of course, to get the square root. And then you can do 9 ABC key 16. Now when you hit that square root key, your calculator automatically brings up an open parentheses. You should use a closed parentheses here before you hit equals.
3/4 isn't the answer.
3/4 is the answer, yes. So even if you forgot the closed parentheses, sometimes it does it right. Yes. What's happening is the square root of 9/16 can actually split up into the square root of 9 over the square root of 16.
These are parentheses?
I didn't do work.
You use it'll automatically, when you hit the square root key, it automatically puts in the open parentheses. Technically, you should close the parentheses when you're done just to make sure the calculator does it right.
So hit second, then
The x squared. It automatically brings up the open parentheses up on your screen, so you don't have to do anything there. Then 9 ABC 16. And then use the close parentheses.
Oh, then I close it?
Yep.
Oh, okay.
Then hit equals.
Oh, okay.
Okay. Technically, what's happening here is simply this. When you do the square root of 9/16, you can take the square root of 9, which is 3, and the square root of 16, which is 4. Just like when we did powers. If I had 2/3 to the power of 5. I could take 2 to the power of 5, which was 32, and 3 to the power of 5, which is, oops, not 81, but 243. And that was my answer. I could take each piece of the fraction to that power separately. The same thing happens with the root. The root follows all the same rules as the powers do. So if I have the square root of 81 over 121, all I really have to do is the square root of 81 and the square root of 121. Well, the square root of 81 is 9. The square root of 121 is 11. Cool. So how does this tie into the geometry stuff we were looking at for earlier? Well, back to triangles. Now this is a special triangle. It has a right angle in it called a right triangle. In a right triangle, of course all triangles have 3 sides, but in a right triangle there's one side that's always the longest, and it's the one that's always across from the right angle. This is called the hypotenuse. The other 2 sides form the right angle, and those 2 sides are called legs. I always say this, the legs form the L. They form the right angle. So when I label a right triangle, I would label the legs A and B. And the hypotenuse is usually labeled side C. So the length of the legs are A and B, and the length of the hypotenuse is C. There's a relationship that's been developed about 1,500 years ago that describes those sides as A squared plus B squared equals C squared. You may have heard it called the Pythagorean theorem. For example, if this is 5 inches and 12 inches, I'm going to label this side A, B, and this will be C. To find side C, well, A is 5, so it'll be 5 squared, plus B is 12, so it'll be 12 squared, equals C squared. 5 squared is 25, plus 12 squared is 144, equals C squared. And then 25 and 144 make 169 equals C squared. But before we're not done yet, because we want to know what C is, not C squared. So how do you solve this? Square root. The opposite of squaring something is square rooting it. So the square root of 169 is 13. So C is 13 inches. Make sense?
All of that gets to 13.
Yep.
All I gotta say is the points better be both sides.
I want to find the missing side here. Remember, there's 2 legs and a hypotenuse. Which one of these sides is the hypotenuse? 17 is the hypotenuse. It's the one that's across from the right angle. Remember, the 2 sides that make the right angle are the legs. So the 15 and the x are legs. So those are A and B. It doesn't matter which one's which. And then, of course, the hypotenuse is always C. So in this case, A is x. So x squared plus B is 15. So 15 squared equals C is 17. So 17 squared. So I'm not going to do anything with x squared. 15 squared is 225. 17 squared is 289. And then we're going to subtract. Minus 225. Subtracting 225 gives us 64. X squared equals 64. So we're going to square root to get that x equals any questions? So let's look at some examples, some applications here. Let's say that we're working at a college, and they've got the dorms here and a cafeteria over here. And the sidewalks are set up kind of like this. And what they're finding is students tend to just cut across the lawn to the cafeteria. They don't take the sidewalk. And what they want to know is what it's going to cost to install a sidewalk across there. Let's say it's 120 feet across here. Let's see here. 350 feet here. They want to know how long this sidewalk would be, approximately. So the first thing we need to do is figure out where our right angle is. Where's our right angle? Right here. Vertical and horizontal always intersect at a right angle, right? So this is 120, this is 350. Those are both legs. So I'll call one of them A and the other one B. And what we're looking for is C. So A squared is going to be 120 squared, plus B squared will be 350 squared, equals C squared. 120 squared is 14,400. 350 squared is what? 122,500 equals C squared. Now we're going to combine 14,400 and 122,500 is 136,900 equals C squared. Now what? Take the square root. The square root of that is 370, I believe. 370 feet. Perfect.
You did that on the top of your head.
I've done this type of stuff a few times before.
Only if you
Only a few.
hard to believe that
What's that?
I said it's hard to believe you've memorized all this.
I haven't memorized it all. Remember, we talked about it before. Math is all about patterns. When you recognize the patterns, and part of it is when I design the problems, there are little tricks I use when I come up with these problems. Notice that I took a second to come up with those numbers. I come up with those numbers in such a way that this comes out to be an exact answer. Instead of being a decimal, I can make that, force that to come out to be an exact answer. When you're talking about right triangles, since I'm waiting for some people to catch up, something called Pythagorean triples. What Pythagorean triples are there are numbers that, when I put them into a right triangle, they form the sides of a right triangle without any decimals. For example, a common one is 3, 4, and 5. That's a Pythagorean triple. Because 3 squared plus 4 squared equals 5 squared. Another common one is 5, 12, and 13. But you can create as many of these as you want to. For example, I'm going to make myself a right triangle here. Pick a number between 5 and 30. 28. Okay. I heard that. It was going to be cool. To create a Pythagorean triple off of 28, take 28 squared is 784. Now there's two different processes. 28 was even. Since 28 was even, we're going to take the 784 and we're going to divide it by 4. Gives me 196. What that means is 195 works here, 197 works here. One up, one down. 28 squared plus 195 squared will equal 197 squared.
Yeah.
Nope, I'm just showing Cody because he was curious. So we square those. If we square root that, get 197. This time, pick an odd number. 13, okay? So 13 squared is 169. Since that was an odd number, we only divide by 2 instead of by 4, which is going to give us 84.5. Also, since it's an odd number, we get a decimal here instead of a whole number. So we're going to go down. This will be 84. This will be 85. We only go up and down by a half. 13 squared plus 84 squared should equal 85 squared. It does. So when I'm making these problems up here, part of the reason why I can calculate them so quickly in my head is I know those patterns like that help me create the problems in such a way that they're easier to calculate. I'm just filling you in on that so you don't think I'm quite so godlike. I can be, you think of me as a little bit, but not a lot.
So, what are you writing on? What, you have a,
This is just a touch screen laptop.
and you have a calculator, whatever. Calculator.
It's just a downloadable app for the computer that I have that calculator on the screen. Yep.
So okay, so I could download one of those onto my Surface.
On your laptop, yes.
It's easier to do it on my Surface than
Yeah. The problem is this one costs money.
with a calculator.
Yeah. This one's about $85.
Oh, easier to find.
But this is and the reason I use this calculator is this is the statistics calculator. The TI-84 is actually does statistics better than Microsoft Excel does on the computer. And I teach a couple of statistics classes for other schools. So that's why I actually bought that one, and I own, that's not WITC's, that's mine.
Okay. Okay.
So you spent $85 on an app.
Yes, but I use it for a couple other classes.
And it's taxable.
Well, and also because I do the same thing for those other classes. I record lectures like this, and it's nice to be able to have that calculator on the screen to show them, especially when you're doing hypothesis testing and you got to go through like 12 different keystrokes on the calculator to get it to do what you need it to do. That calculator does wonderful things, but it's complicated.
Do you know how much I wish I could teach for the lectures? Oh no, that's what it is. I have to play minutes.
What was that?
Oh, I'm only taking the class second time because the wife from last year.
Let's say that we have a window that's 25 feet off the ground. And we're going to set a ladder up there so it's directly right at the bottom of that window. And our ladder, I'm going to cut this back. I'm going to make this 24 feet, make this work better. And our ladder happens to be 26 feet off the ground. Now you think that 24 or 26 feet long. 24 feet and 26 feet are pretty close to the same. Is that ladder going to get much tilt on it? You might think, no, really, 2 feet is not going to tilt hardly at all. Well, how far away from the bottom of the house is the bottom of the ladder going to be? Here's a right angle. Hopefully our wall of our house makes pretty close to a right angle with the ground. Well, let's check. These two sides here are the legs. So I'll call this one A and this one B, and of course this is the hypotenuse, C. A squared plus B squared, so B is 24. So A squared plus 24 squared equals 26 squared. 24 squared is 576. 26 squared is 676. We're going to solve for A squared, so we're going to subtract the 576. So A squared equals 100. And then square root. A equals 10.
Can you look at
five
something,
ways.
something like that when you're doing your construction? Can you just look at something like that and just like do it in your head?
Yeah. But like I said, there are patterns that you fit things into. So there is a quiz due tomorrow at 11:59 p.m. This is the one that was originally set that was due on Tuesday, so some of you may have already done it. I did change the date and I added a couple attempts, so if you've already done it and you want to do it again, you can. You don't have to if you've already completed it.
Oh, so that's why mine was showing up with another quiz on Thursday.
Yes. Yes.
But these English stuff isn't on it.
No, this is going to be on the new homework. There's a new homework. This new homework is actually set to be due tomorrow, but I'll give you extra time because it's a short turnaround.
Okay.
There will be a new quiz starting tomorrow that'll be due Friday, just so you know. You're going to get 2 quizzes in a row here, 2 days in a row with quizzes.
Oh.
Because of that survey on Monday. And I apologize for that. And if we need to, we can extend stuff.